Okay, today we're going to have a look at bearings. Bearings are using angles to help us find direction, and there are two ways that you can express an angle in terms of a bearing, a compass bearing or a true bearing. Now, a compass bearing comes in two parts. The first is the north-south part, so basically, is it in the northern hemisphere or the southern, okay? And then the east-west part. So is it east or is it west? Okay. Whereas a true bearing always starts at north and travels in a clockwise direction around here. Okay. So the compass bearing will always be between 0 and 90 because you're talking about which quadrant, the northeast quadrant, the southeast, the southwest, or the northwest quadrant. Whereas the true bearing can be anywhere between 0 and 360. So let's have a look first of all. South 20 degrees east, okay, means that you start at south and you go 20 degrees towards east. There it is there. So that is the direction that you would walk, okay? North 40 degrees east means you start at north and you go 40 degrees towards east. So that would be 40 degrees there, and that's the direction you would head. Now, a true bearing, you start always at north, true north. We don't worry about magnetic variation, if any of you have done that with orienteering. And we go 120 degrees. So I always draw this one in and I go, okay, starting, that would get me to 90. I've got to get to 120. So if that's 90, I need to go an extra 30 degrees to get to 120. So that's the direction I would take. Okay. If it's 300 degrees from true north, okay, I'd be coming around, there's 90, keep going, there's 180, okay, keep going, there's 270, and I would have to go another 30 degrees to get to 300. So that would be my angle there. So that's the first thing, you need to be able to do angles in both, and I've put some little practice questions there and you can check them on the solutions. Right, now to actually do an example. Now try to do a really quite big diagram, and if you've got a protractor, it doesn't hurt to actually use it to actually make your diagrams fairly accurate, otherwise they can be a bit misleading, okay? Alright, so a boat travels a distance of 5 kilometres from P to Q in the direction of 35 degrees true. Okay, so I'm going to do 35 degrees true. So I'm just going to, it's a bit dodgy, isn't it, as a protractor. Okay, 35 degrees is about out that way. So there, 5 kilometres from P to Q. Okay, and that's, oops, I measured the angle wrong, sorry, that should be 35 degrees in there. Oops. So that should be 35 degrees. Oops, should be out there. 35 degrees, 5 kilometres. There we go. Okay, from P to Q. Oops. Okay, how far east of P is Q? So this is the easterly direction. So that's actually asking me to find X. How far north is P of Q? So that's actually asking me to find the Y there. And what is the true bearing? Well, they actually gave you the true bearing. I think they mean compass bearing. Now the compass bearing here would be north 35 degrees towards east. Okay, so that's the answer if it's a compass bearing. Now let's find X and Y. It's a right angled triangle, so we just want to use Pythagoras. We want to use our ratios. I'm going to find X first, which is opposite. So I'm actually going to use my sine ratio, opposite on hypotenuse. So sine of 35 equals X over 5. I'm going to multiply by 5 on both sides. And do that on my calculator. 5 sine 35 gives me 2.87 kilometres. Now for B, I'm using cosine, or you could actually use Pythagoras because you've got two sides. You could find the other side using Pythagoras. Cosine is adjacent on hypotenuse. Cos of 35. Now the adjacent is y over the hypotenuse, and multiply. And then our answer we can do on the calculator, making sure we're in degrees, is 4.1 actually, kilometres. Okay, and that's it. All right, example number 2. A boy walks 2 kilometres on a true bearing of 90 degrees T. Now 90 degrees T would actually be in an easterly direction. So he walks 2 kilometres east. Then he walks 3 kilometres on a true bearing of 130. Now, this is where it gets a bit tricky, okay? So he has walked from here to here. So he's now at this point. So this is where we need to draw another compass point, because if you get to a point and you've got another direction to take, you take out your compass. I'm going to do the second journey in red. He's travelling on 130 degrees T. So that would give me 90. I'm going to have to go another 40. So that angle in there is going to be 40 degrees. And he travels that direction for 3 kilometres. Okay? Now, a good idea is to put in any other angles that you know. For example, I know that this little angle in here is 50. Okay, that might come in handy because that's a 90 degrees. How far east of the starting point is the boy? So we actually want to know how far east he is. We want to know that. How far south he is. So we want to know that. So we want to know x. We want to know y. And what is the bearing of the boy from the starting point? Okay. Now, what I would do here, I'll bring that triangle down there. I already know that that's 2 kilometres. So if I find out this part here, let's just call it A, because I've already called the whole thing X. If I find A, I can add it to 2, can't I? Right? And in terms of Y, well, that is Y, so I can find that one. I can either use this angle of 50, or you might notice that there's a Z in there, and this angle here is 40. Doesn't matter which angle you use. Okay? I'm going to do sine of 40. Always write your rule first. Equals opposite over hypotenuse. Okay, so that's going to give me my y value, 3 sine 40 on my calculator, which is 1.93. And then I'm going to use cos to find the x value. Cos 40 equals x over 3. Okay, 3 cos 40, which gives me 2.3 kilometres if you're rounding. So for A, it's actually 2 plus 2.3, remember, okay, which gives me 4.3 kilometres. For B, it's 1.93 kilometres. Okay, now for part C, what is the bearing? That's a bit tricky. Now, from this position, he would take out his compass and he wants to go back to the starting point. So let me draw back to the starting point because it's a bit tricky. Okay, so we actually want to know that angle around there. Now, because there's not a right angle triangle, it makes it a little bit tricky to actually work that one out. until we do a different rule. So just leave that one out for now, okay? And we will do the sine rule soon where we can actually work that out. Right? So now you can do exercise 4D.